Hello. In this session, we evaluate substitution and addition reactions. Namely, a substitution reaction is a reaction in which principal hydrogen atoms in a hydrocarbon are replaced in the presence of ultraviolet light in order to effect the reaction process. Addition reactions, on the other hand, are reactions involving unsaturated hydrocarbons such as alkenes and alkynes, in which the principal double bond is broken or the principal triple bond is broken to create room for addition of external species. Welcome. To enable us to evaluate it, we are going to use three principal tests and examples in the stoichiometric form of a reaction between a hydrocarbon and respective halogen species. Take a look. So, as you've heard, we are going to compare and determine what type of reaction occurs and then proceed to represent the procedures. First, you are told identify the product in each chemical reaction below and state the nature of reaction occurring and then the reaction conditions employed thereon. Number one, we have C2H4, which I can see clearly is an alkene reacting with a halogen in form of bromine. The alkene is ethene. There is a double bond between two successive carbons, and they have hydrogen surrounding each carbon, and they meet a bromide molecule which comes in form of a bromide ion, because one, the bond between bromine and bromine has to be broken before addition occurs. However, since this species is saturated, it is unsaturated because of the double bond. Since it is unsaturated, there is the chance for effective breakage of the bond. And as I give the mechanism, it shows that the double bond is going to be broken to become a single bond. And in that process, a bromide atom is going to be attached. And when the bromide atom is attached, the hydrogens which were present are retained in their respective position. The breakage of one of the bonds, remember each bond is made up of an electron on one side and an electron on the other. So when the bromide comes in, it comes in with its own electron. It joins in on the pair of electrons, takes one and forms the bond. And in this respect, it leaves another electron which becomes polarized. That provides room for the second bromide to join. And when it so joins, it forms an attachment. And the ultimate result is that we have two bromides attached in the previous molecule, which was unsaturated and now has been rendered saturated by virtue of breakage of the bond into a single bond. Now, what is this species which has formed? This species is bromine in two positions, so it is 1,2-dibromo ethane. And therefore, when we are representing it, we will represent it as the molecule represents CH2Br, CH2Br. That is a principal view of what has happened, and we can agree and say that when ethene meets bromine, it undergoes the addition reaction. It undergoes what? The addition reaction, simply because the reacting agent is unsaturated. In this case, no principal reaction condition are required. No conditions required. Except that of unsaturation. Period. Looking at the second example, we have C2H4 and bromine And I will want to change this into C2H6. That must have been a misrepresentation because it's the same procedure. Now in C2H6, we can see that this is ethane, which in my view is saturated, in which two carbons, each holding a network of 4 hydrogens, has no room for addition. So it is saturated. Being saturated means there is no room for addition. Now, when there is no room for addition, we can only proceed in assuming that the attacking species or molecule will have to displace the present atoms in the molecule. In this case, we have bromine, and bromine is in molecular form, which means it is inert. The prerequisite, therefore, is that we must have ultraviolet light. And the ultraviolet light will have the role of breaking the bromide to bromide bond. So that is UV light. And when it breaks the bromide to bromide bond, it creates a bromide ion. The bromide ion is electrophilic, meaning that it is electron seeking and will proceed to the act of displacing the less electrophilic species hydrogen and assuming its position. What is the net result? The net result is that there will be a replacement of one hydrogen by the incoming bromide. And when that happens, the structural representation will be as follows. Hydrogen has been displaced and its position has been taken by a bromide. And therefore, the resultant molecule is bromoethane. Now, when bromoethane is formed, we represent it molecularly as CH3, CH2, and Br. A clear representation of a replacement of one of the hydrogen in the outer methyl by a bromide. The reaction condition, we have said, is the presence of ultraviolet light. Period. And therefore, the reaction in which a saturated hydrocarbon meets the halogen does not proceed in the absence of UV light, but in the presence of UV light, it undergoes a replacement of a principal hydrogen in the process referred to as substitution. Therefore, saturated hydrocarbons undergo substitution reactions in the presence of ultraviolet light. Next, we have a species represented down here. In this case, I can see this is an alkyl, and this alkyl has two carbons. So we could name it respectively as ethyne. Now, ethyne with the triple bond has an enriched center which is unsaturated, carrying a set of triple covalent bonds. Therefore, an attack by a halogen such as a chlorine would infer the breakage of the lower bond, creating 2 points for principal addition of chlorides, breaking of the second bond on the upper end, creating another 2 points for chloride additions. The end result is that we have the ethyne reduced into ethane with 4 principal additions of chloride atoms. And in this case, we have 1,1,2,2 tetrachloroethane. So 1,1,2,2 tetrachloroethane is the final result of a reaction which we are describing as addition. So this is an addition reaction simply because no reaction conditions are required except for the condition that the reactant is unsaturated with respect to having a triple bond. And therefore, this reaction is an addition reaction that forms 1122 tetrachloroethane. In summary, therefore, we have described in this section are two principal forms of organic reaction, namely the substitution reaction, which principally affects the saturated hydrocarbons, in which there is a replacement of a hydrogen, but the condition is that there must be ultraviolet light to break the bond between a halogen molecule to make it active or electrophilic. Number two, we have seen that the unsaturated reaction involves an addition by the breakage of the unsaturated bond. In this case, addition reactions occur where the reactant is unsaturated with a double bond or a triple bond, providing room for the breakage and creation of room for addition. Finally, inasmuch as we know that organic compounds are chemical agents just like any other, and that there are different chemical processes including neutralization, substitution, displacement, and many other varied range of reactions, it will be of key concern, however, to note that the principal reaction processes of organic compounds are those of substitution and addition. When it comes to organic acids, on the other hand, or carboxylic acids, we can infer that being acids, they have the tendency to undergoing neutralization processes, which in a nutshell represent the process of displacement. Thank you.